Welcome to a new lesson. In this lesson, we learn about combiner functions and make a little enhancement in our driver class which we wrote in the previous lesson. Let us again look at the solution which we discussed in the previous lesson with simulation of parallel maps running. Let map 1 get input 1, to be or not to be, and second map get the input as shown. After being fed to map, they would produce their respective outputs. When this is fed into a combiner function, it would produce outputs as shown. It is recommended to use combiner function in your solution if it is possible. The function of combiner is to process the map output locally so that there are less results to transfer to reducer. So in this, what we can do is that we can add up the occurrences of the words on the map machines locally, and this can reduce the map output. And so you would see that the combiner function has compressed the map 1's result. In this example, the second combiner didn't have the repeated words and hence didn't reduce the output. So we can see with this example that the idea behind the combiner step is to reduce the load on valuable asset in Hadoop processing, that is, its network bandwidth. Always it is recommended to have as less map outputs as possible so that it is easier to transfer the map's output. In this case, combiner is doing nothing but the same thing which we are doing in the reduce phase. It is adding up all the values of the keys, just that it is performing the same thing locally on the map machine, and reducer applies it to the global data which is collected from various maps. The rest of the steps are the same as we have seen earlier. The combiner's output would be sorted, shuffled, and partitioned and fed to the reducer, which processes and produces the output. Let us look at the key points with the combiners. If you write combiner classes, they'll extend the reducer class. When thinking of combiner, think of reducers which are happening locally on map machines. So program structure wise, they're exactly the same and extend reducer class, like the reducers do. The combiner's logic would be written in reduce method exactly in the same manner as we discussed for the reduce class. Second key point is that these can be applied only in the cases where the nature of the problem is commutative and associative. It is just a complicated way of saying that the operation done by combiners should not depend on the order of the values that are treated to combiner operation. Let me explain this. First, I will brush up about the associative and commutative laws. Commutative law is A plus B is equals to B plus A. This means we can swap the operands and yet get the same result of the same operation. Associative law is A plus B plus C with A plus B grouped together would be equal to A plus B plus C with B plus C grouped together. This means that even if the grouping of operands is changed, the result is the same. The reason we need these laws to apply is because combiner step can run more than once on map's output. We would learn about this in details later. But the key point is that combiners can run multiple times so as to reduce map's output. In case of reruns, the manner in which the values is processed is often random. So the operation performed by combiner can have the same values in different order with every run. Thus, this change in order should not change the overall result. And so the combiner function should have the operation which follows associative and commutative law, or else we would get erroneous results. In our case, the operation is of simple addition and hence it is fine. Something like an arithmetic mean won't follow this rule. Third, and the most important point, is that implementation of combiners reduces the transfer of the data between maps and reducers. It is the most important and underlying idea of combiner. If combiner doesn't perform this, there is no point of its design. Let us look at a program which implements combiner function, and at the same time we would learn a new and a better way to implement our driver class. First of all, setting our combiner function is as simple as writing a single line of code where we pass the combiner class to the function job.setCombiner class. We would reuse our reducer class in the program as it is performing the same function. So if you want to use your combiner class, you just need to write the processing logic in a class and pass it through job.setCombiner class function. The combiner class code would extend reducer class and would be coded in the same way as reduce class as we have discussed in the previous lesson. Now we look at one more change we have done to the code. In the previous driver class, we had written our logic in the main function. Here we have extended configured class and implemented tool interface. And in the main function, we have just used toolrunner object to trigger the run function, which has all the logic in exactly the same manner. What this does is that it gives ability to set properties at the runtime, and we need not write a single line of code to handle them. I'll explain this with an example later. First, let us try to run this program in the usual way. I would just export the jar file. I would override it. The first thing I'll do is to check if all the daemons are up and running. I'll do this by jps command. In this case, all of them are running. If not, you can start it with start-all.sh command. Let me do an ls on Hadoop file system. I would just cat the in file right now. So it has only one line, to be or not to be. I would suggest you to put more lines in the file and try to experiment a little when you finish this lesson. I'm in the bin folder itself where I've exported the jar file. Let me do an ls on the local file system so as to check if the file is there. Okay, there it is. Now I'll run the program with command hadoop jar wordCount.jar then the driver function, which is word count with combiner, then in and out2. Out and out1 are already present, so I choose out2 directory. There we see the program running. Let us do an ls on Hadoop file system to see if the output directory has been created. Now let us do an ls on out2 directory. So there we see the part file. Let me just cat it. So there's the result. Now let us see the magic toolrunner brings to our code. Now I'll run the same program and set up the job to run without a reducer. Now just after I have mentioned the driver class, I would do a hyphen capital D space mapred.reduce.tasks equals 0 and then give the in file and the out directory. If you notice that we need not exclusively code for handling these parameters as we have used toolrunner object to run the code. We can here specify as many properties as we want with -d followed by the property name, and toolrunner would be able to handle it. Let us press enter. the job runs to completion with reduce as 0%. Let us see if out3 got created. There it is. Let us see contents of out3. So there we see the part file with M, which indicates a map output file. Reduce output file will always have an R there. Let us cat the part file. And there we see the output. Here we get to see the map output exactly the same as we had discussed in simulation runs. Now I would suggest you to add a few lines to input and play with the properties such as setting up reducers to 2 or set up maps to 2 and reducer to 0 and see 2 maps output and so on.